So while fixing of hardware, one thing we need to ensure while fixing of the spag, the handle, your hinges, key that the overlap between the frame and sash should be at least 8 mm. Overlap that I will show in the next slide as I was showing you, where the frame and sash are having a little bit of common area. Okay, that common area should be at least 8 mm. Some companies do prefer 10 mm also. So normally it varies from 8 mm to 10 mm and it shouldn't be less than 8 mm. Otherwise, what will happen? The reason why we need this and what is this overlap? This see. So here, as you can see, the sash and frame, okay, they are sharing this common space. It should be at least 8 mm here and 8 mm here. The reason, as you can see, here is one gasket and here is one gasket. And these are the two gaskets which are giving 100% sealing to our casement window systems. And just imagine if we compromise the overlap, okay, and this gasket is not properly coming on the frame and here it is not coming on sash. So what will happen? There would be some gap and from this gap air would enter, sound would enter, so our 100% sealing would be compromised. So that's why, so that this gasket is completely covered and perfectly compressed while we close the sash, we ensure that this overlap should be at least 8 mm. So what is locking system? It is a system which is helping us in operating of window, closing and opening of window. So locking system is of two types, single point and multi-point. As the name suggests, single point is a system where the locking is happening just at one point. And multi-point where the locking is happening at more than 1 point. So here we'll see example of single point locking system in a casement window. So the handle which is giving single point locking in casement system is called a cockspur handle. Okay, and so this handle is fixed in the sash and this wedge, it is fixed in the frame. So this point here, it goes and locks in the wedge. So as you can see, it is giving locking at just single one point. So that's why it is a single point locking handle. Now let's see what is a multi-point locking system. So as the name suggests, multi-point locking means which is providing you locking at more than 1 points. It could be 2 or more. So multi-point locking system is made of, firstly, there would be a handle. There would be an spag. Spag is very important part of a multi-point locking system. Wherever there is multi-point locking system, this spag would be there. Its full name is spagnolet, but in short form, we use the word spag. And then there are the strikers. Strikers are the points where this cams of spags are going to lock. We will learn about spag in details in next few slides. So as you can see here, there are two strikers and here there are two cams in this spag. So this window is giving locking at 2 points. Okay, so here is our casement window spag. So here is a model of a spag. So this first entire plate on which the spag is there, it's called a base plate. And this, it is a mortise portion or gear portion, which is doing all the work. Then we have a hole for the spindle. What is a spindle? We'll learn later. But basically, it is a rod kind of thing, which is coming out of the handle. So the handle is in touch with the spag at this point. Then these are the holes for the screws. And as you can see, these points, this one and this one, these are called cams. Okay, cams are the points which are going to lock in the frame with the help of strikers. So strikers are fixed in frame. So these cams are going to lock itself in the strikers which are fixed in the frames. So what are the two aspects, main aspects of spag on which you are going to select a spag for your profile? Firstly, the length of the spag. The length of the spag varies from 400 to 2000 mm in case of window spag. Okay, we are right now we are talking about window spag. So, and it goes on from 400, then after 400 it will be 600, then 800, then 1000, then 1200. Like this, 200 gap would be there in the length of a spag. And how we're going to select the length of the spag? It will depend on the height of the sash. Then a very crucial point is the back set. What is a back set? Back set is the distance from the base plate to the center of the spindle hole. This is called the back set. So while you are going to a hardware guy for selecting the spag, then you would be telling him that what backset spag you require, and it will depend on the depth of your profile. So the aesthetics of the profile will be measured first, and then you could select the spag based on the backset of your on the backset of the spag. And normally a 20 backset works perfectly for the casement windows, but we can make it universal. So you must always check the depth of the dimensions of your profile before selecting the fag. And while selecting the length of the spag, what Udma suggests is that, for example, the inner sash height, that is the height inner one from here to here. Okay. So if the inner sash height is between 400 to 600, then you can go for a spag of length of 400 So you can maximum take a gap of 200 It is suggested by us to give you, perfect locking. In many cases, some companies, what they do, their sashes are of big, huge height, and they are using very small spag. So that doesn't work perfectly because that won't be giving the perfect locking. So as you can see, if there is a internal sash height is from 1200 to 1400, so you could go for a spag of 1200. So maximum distance, the maximum gap which we are considering between the inner sash height and the required spag length would be 200 So what are the cams? See, as you can see here, the cams are the points in the spag that locks in the strikers, which are fixed on the frame. And mostly number of cams are 2, then 3, then 4, and it will depend on the height of the spag. And cams are of two types. In casement window spag, the cams are roller cams. And in case of siding spag, the cams are mushroom cams. So right now we are studying about casement spag. So the cams here are called roller cams. So now let's see the part of the handle. So first is the base width. Base width is the width of the handle, the area which it is going to cover when it is fixed in width wise. And this is called the spindle. So as if you remember when I was telling you about this bag, I told about the spindle hole. So this part is the part spindle which goes in that hole. So when you will be moving your handle, your spag would be also performing. The cams would be moving up and down. So spindle length, it depends on the aesthetics of the profile, the depth of the profile. And its dimension, its width is 7 by 7. In all, it is universal. In every handle, the width would be 7 by 7, but the length, it would be depending on the profile that you are using. Okay. But I'll tell you here. So here are a few types of multiple locking handles, as you can see. It is a L handle without key. It is normal L handle. It is handle with key, and it is a cranked handle. As you can see, here is a little twist. That's why it is called a cranked handle. But the only thing is with the cranked handle, For example, this handle, okay, it is centrally placed. So we can use it in the left side opening window also and the right side handle window also. But these cranked handles, we can't use it in both. So they are separate. As you can see, it is tilted here. So there are different types. Okay, for left side, we'll be using different handles. On for right side, we would be using different handles. So that is the only drawback for a cracked handle, because then for stocking it's a little bit problem, because then you have to keep a separate stock for left side handle and separate stock for right side handle. Okay. So as we saw the base width of a handle, so right now we are having an outside opening casement window. Okay. So if we have a closer look, so as you can see, the space, okay, the space, we don't have much space for fixing the handle. Now let's just look here at the profile cross section. It is our frame, it is our sash. Okay, so we have got just this much space for fixing the handle. Okay, this is in the case when we're talking about an outside opening casement window. Okay, so here we are not having much space, so we cannot use handle of big base width. So a maximum base width we can use up to 18 mm, but it also depends. If you are using a profile which is not much in width and it is much smaller, then maybe we have to use even a smaller handle of lesser base width. Okay. So in case of outside opening casement window, we are not left with much options. We can only go with these types of handles which have lesser base width. Okay. These ones we can't use because their base width is huge and they can't be fixed in this area. So here are a few points. I'll make second one. Right. As now see, just I'm gonna give the full attention here. This is a frame. This is a sash. This is the spag. Okay, here we're fixing the spag. Cranked handle application is, it's, I mean, some people just use it because it is very easy to use. As you can see now, there is a little crank. Okay, it's twisted, tilted a little bit, so it is very easy to hold it. Okay, usko hold karne mein aur usko operate karne mein, it's very easy to operate and hold as compared to normal straight handles. That's why people, because usko kya hota hai na, half of the twist comes on the glass side, so you get enough space to hold the handle. Whereas in case of normal L handle, you are not getting enough space for the fingers to go in. That's why people do prefer cranked handle over normal handles. Okay. So now let's come to this one. As you can see, this is our frame, this is our sash, this is our span. Okay. And this is the center of your sash profile. No voice. Jai is telling no voice. Am I audible, everyone? Yes. Okay. Everybody is saying yes. Jai, please check something at your end, because I am audible to everyone else. Okay. Okay, fine. Thank you so much. Huh. So it is the center of the sash profile, which should come where, at the center of your spindle hole. So this is the reason why we need to select our back set. Okay, because this is the area which it has to go, and somehow this thing should fall in the center of your sash. That's why it's very important that you select the back set of your spag based on your profile aesthetics. So this is the back set where we were talking about, from the base plate till the center of the spag spindle hole. And this is how your handle spindle. Okay, this is the spindle. This gray thing which you can see is the spindle, and it goes in the spindle hole. So when you will move your handle here, your is going to perform. This is your handle, this is a spindle, and this is your base width, okay, which we were talking about. This is the overlap. Yes. One thing while fixing, as you can see, we have just this much space left for our handle. Okay. So one thing which we must ensure while fixing, that your overlap is not compromised. Okay. For example, if you have used we'll come to the questions at the end. Okay. Otherwise I just lose my flow of my lectures now. That's why we'll take the questions at last. So where was I? Okay, so we must not compromise the overlap. For example, you don't have much space for the handle, okay, and you're using a larger base width handle. So what will happen? You will use this space, and somehow you need to drag your sash outside, and there you are going to compromise your overlapping. So while fixing the handle, we must always ensure that you're not compromising your overlap. And at the same time, as you can see, there is a slight gap between your gasket and your handle. So to fix your handle, you should never, while fixing the handle, this must be ensured that your handle is not touching the gasket, because what will happen when you by uh, reusing and opening and closing your handle, your gasket will get damaged. And once your gasket will get damaged, of course, the thing which we are promising, airproof, soundproof, thermal proof, everything will be compromised. So we need to select the base width so that firstly it goes properly in. Secondly, your overlap shouldn't be compromised. Thirdly, it shouldn't touch the gasket. The same thing which I've told you, firstly. And one more thing, when you're inserting your spagger, ensure that there is no gap between your spag should not touch the reinforcement. There should be some gap between the reinforcement and the spag. Firstly, because if it will touch it, then what will happen after so many operations? As I think you all know that this reinforcement, it is galvanized iron. That means it is an iron which is dipped in zinc. And because of that zinc coating outside, it is not getting corroded. Okay. So what will happen with due usage, this reinforcement is gonna scratch, and the zinc layer is gonna be removed, and then it will start corroding due to moisture. And one more thing, and while inserting the spindle also, you should ensure that it shouldn't touch the reinforcement. Firstly, as I've told you, because of this thing that the zinc layer will remove. And secondly, what will happen, just imagine if this thing is touching it, okay, then what will happen? The operation of the handle won't be smooth, okay. Every time you will be moving it and it's touching here, so it won't be moving smoothly. So you must always ensure that this spindle doesn't touch your reinforcement. Then as I've told you that we must ensure the gap should be 8 mm, and there should be a gap between the gasket and the handle, so that the gasket doesn't get damaged. Okay. So lastly, we talked about outside opening casement window. Now we shall see the case of inside opening casement window. So as you can see, in case of inside opening casement window, we are having a huge space to fix our handle. So in this case, we have no problem. So in case of an inside opening window, as we are getting a huge space, to fix the handle, we can easily go with any handle. Okay, till your profile permits it. So in this case, we can go with a big, huge base width handles also. In case of our inside opening casement window. This is a outside opening casement sash. So normally these are the universal holes. Okay, when we're using this type of handles, whereas there is one spindle, and there's two screw holes. So the gap between the two holes is 43 mm, and the gap between spindle hole and top screw and spindle hole in the bottom screw hole is 21.5 mm. Okay, it's same. It's same in all handles which are of this type. This dimension and the gaps are exactly same. And in fact, on the machine also, this thing is fixed. You don't have to fix anything. It's set at these dimensions. Now let's come to hinges. So hinges are the hardware which is used to attach the the sash to the frame, and they're helping in the movement of the sash. So we can open and close the sash. Second piece. So normally there are two types of hinges, butt hinge and the friction hinge. Butt hinge normally are 3D, 2D, but in casement windows normally we use 2D or these types of hinges which are not so visible. And then we are having friction hinges. So what's the difference between a friction hinge and a butt hinge? Okay, so butt hinges are fixed on the side, whereas friction hinges are fixed on top and bottom. In this, as you can see, the sash is very close to the frame, okay? And when we are opening the sash, then also the sash and frame are very close, okay? There is no gap between the frame and the sash. And now here, in this case, as you can see, when we are opening the sash, there is a gap between the frame and the sash. The reason why people do prefer this gap because especially in case of high-rise buildings, it's not possible to clean the glass from outside. Okay, in this case, we can't clean the glass from outside. But in this case, you can easily put your hand out from this gap and then clean the glass from outside also. And here, normally the butt hinges are used in the quantity of 2, 3 also we can use, but more than 3 or 4 we are not using butt hinges. And on what it depends, we will learn later in next few slides. And it is the number will always be 2. And butt hinge normally we use 2 to 3. Normally 3. In smaller windows we can go for 2, and in larger windows we can go for 3. So here sash is free to move because when you will be opening a sash and if wind flows or air flows, okay, the sash will move freely. Whereas in this one we have a restricted movement. Okay, even if we want, stop. We can stop the sash at any place. Okay, 2D and 3D hinges. 3D hinges are mainly used actually are for these are very heavy hinges. They're expensive also, and 3D hinges are mainly meant for they are never used in windows. They are used in casement doors. Okay, and they're heavy duty. They have much more power strength to hold the heavy sashes. So how we're going to select a friction hinge? Firstly, we should go for a corrosion-free base material, that is SS304. Okay, it is at least this we should use so that it doesn't get corroded and it doesn't catch rust. And one more thing, just a small example I want to tell you, because what happens now, we normally go for very good hardware, SS hardware and everything. But while sometimes we don't use good quality of screws, then what happens? He, for example, if you haven't used SSS screws, you have just used zinc coated screws. So you have installed your friction hinge with your zinc coated screws or low quality steel, which can catch rust. So what happens once your zinc coating is removed or your low quality screws get rust, so that rust is spreaded to your spag also. So that's why it is very important that not only your main hardware, but you should also use good quality screws so that your main hardware doesn't get impacted or get corroded just because of very cheap thing, that economical thing. Screw doesn't cost much, but even 1 rupee screw can make a difference. Okay, it can corrode your entire main hardware. Now we shall come to the longevity test. What is a longevity test, or it's called operating cycle test? Uh, Okay, so I think you saw this apparatus in this video. So it is, these type of apparatuses are in the labs. Okay, so these, all this hardware, just like this handle, this friction hinge, they are tested for certain number of cycles. For example, your hardware provider has tested your hardware certain X friction hinge for 25,000 cycles, and he guarantees you that it is we tested for 25,000 cycles. So that means that that hardware will at least live for 10 years. It can give you 10 years guarantee because on an average we open and close a window 4 times a day. Okay, so if we will multiply it by 365, so and in an year we are using a window hardware, I mean, for closing and opening for at least for 1460 times. And now if we will look it for 10 years, it will be 14,600 times. So, and already this hardware is being tested for 25,000 operating cycles. So there you can always guarantee for 10 years. Similarly, some hardware companies, they give that, I mean, they do these tests for 50,000 operating cycle tests. So you can always ask your hardware company provider that for how many operating cycle tests your hardware has already passed. So according to that, you can convey it to your clients. Load bearing capacity. Okay, it is a little bit technical topic. We need to learn some calculations. So type yes, if you want to learn this calculation. Okay. Okay. It's a big yes from Mr. Ankit Khanna. Ayush says yes. Karan Shah says yes. Okay. Then if it's a big yes, then I would request you to please take a notepad and a pen. Okay. Please just 2 minutes, quickly go away, run away, and I mean just bring your notepads and a pen. In the meanwhile, I'll see that there was a question. Before that, I mean, let me just explain you. Okay. So, what are the major components? Okay, which are which are responsible for the weight of our window. The main components are our profile, the reinforcement, and the glass. Other things are very small things. Now there's handle, spag, other things are very minor things. But the major parts which are contributing in the weight of our sash is the profile, the reinforcement, and the glass. So if we come to know the weight of the profile, the reinforcement, and the glass, then of course we will be able to add them, and we will able to get the weight of the sash. So for calculating the weight of the profile and reinforcement, okay, this is a question actually. So we will see. Mm. So for taking out for second for calculating the weight of the profile and reinforcement. Okay, that we will calculate later. For that, first we will calculate the running meters. Okay, how many running meters of profile and reinforcement we are using. So for what for that what we'll do, width plus height plus width plus height. Actually, it is in mm. So first we need to convert in meter, or later on you can convert it in meter. Okay, so this we are calculating in meter. So first step what we have done, we are calculating the running meters of the profile and reinforcement. For that we are adding width, height, and we have done it in meters. Okay, first step is to take out the running meters of the profile. Then to calculate the weight of these running meters of the profile, we multiply it by 2.4. But why do we multiply it by 2.4? Because it is said that, I mean, it's not universal. It could change, but normally on an average, it has been calculated that per meter weight of one profile plus reinforcement comes to 2.4 kg. But if you know exact weight of your profile and your reinforcement per kg weight, sorry, per meter weight, then you can put that value instead of this 2.4, you can put exact value of your profile plus reinforcement. Okay. For example, you are using X profile and the weight of the casement sash of that profile plus reinforcement comes to 3.6 kg per meter. Then instead of this 2.4 kg, you will put that 3.6 kg. Okay, now Ayush is telling me no audio. Am I audible? Yes, yes, yes. Okay. So if you haven't heard me, let me repeat once again. The very first step for calculating the weight of the sash is to calculate, because the three main as well as the reinforcement is big. So of course, this value will change. So this value can vary from profile to profile and reinforcement to reinforcement. So this you can change as per your profile and reinforcement. Okay, so this is how we have got the weight of the profile and reinforcement. And now the next step is to calculate the weight of the glass. So weight of the glass, because here we were calculating running meters, but as you know, glass has a area. So here we will calculate first the area of the glass, width into height. Here we have got the area. Then as you can see that the glass is a 3D thing, right? So the area won't be enough. We also need the thickness of the glass. Okay, so width into height into glass thickness, and then the way we have multiplied it here with the 2.4, here we multiply it with 2.5, because it is considered that per square meter weight per mm of a glass is 2.5. That's why width into height into the glass thickness, because you can see here the glass thickness is 6 and then 2.5. It is this you can consider as universal things. Okay, so Mr. Mohammed Sultan is telling that 2.5 is the density of the glass. Thank you so much. Okay, so it is 2.5. So here we are multiplying it with 2.5. So it will always remain constant. We won't be changing 2.5. Okay, so what will be changing? We'll be changing our width, our height, and the glass thickness. So then we get the weight of our glass, and then to get the final weight of our sash, we will add both of them. The weight of the profile plus reinforcement plus the weight of your glass. So it comes to 30.54 kgs. So now depending on this sash weight, you are going to select your hinges. So you have to select the hinges which can support a weight of 30.54 kgs or more. We won't be going for a hinge who are not supporting, for example, X hinges supports a weight of 25 kgs and Y hinges of 30 kgs. Then you will be opting for Y hinge, not for X hinge, because in future if anything happens, anything wrong happens, then you can't go and claim anything from the hardware company. For example, now here you can see these are the product range of McCoy Thunder series. So here they are specifying the weight of the hinge which can withhold that weight. So you have to select your hinges depending on the weight as well as the length of your hinges. For example, if your sash width is lesser than 24 inches, but its weight is more than 30 kgs, you can't go with this, because how will you install a hinge which is 24 inches and the sash width is lesser than 24 inches? So you have to go with another series, okay, where the sash width would be lesser and which can carry that certain weight. So I think everybody knows. So let me now you have learned. So have you understood the formula of carrying the sash weight? Then I'll ask you some. Then we shall do one question then. If type a yes if you understood it. Good, 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 good. Okay. So now let's do a question to check who has. Okay. So I have a glass. I have a window. Okay. Width is 1100. Height is 1500 and the glass is 5 thickness. Please calculate the weight. I'll repeat myself. 1100 width, 1500 height and 5 thickness glass. Okay, there is a question from Mr. Karan Shah that 30 kgs. No, it is always whenever a friction hinge, it's been told, it is for a pair. Okay, it is not for one friction hinge. The weight carrying capacity is for a pair, not for a single one. Okay, Jaya has already calculated it. Let me also calculate it on my calculator. Just a second. Then I can tell you that we are doing right or wrong. Height is 1500. Okay. 1100 by 1500 and our glass is 5 thickness. Jaya has already got the answer also. Very good job. Jay, I think you have done some mistake. Your answer is wrong. Mr. Ankit's answer, Mr. Ankit Malhotra's answer is right. Ayush wrong. Right now, only Mr. Ankit Malhotra's answer. Yeah, Ayush, now it's right. It's 33.10. So the answer is 33.10. So right now, till now, Mr. Ankit Malhotra's and Ayush Khosla's answer is correct. Okay. So now let's move to our next section. The load distribution. Load distribution means the how the weight is distributed over your spag. Sorry, your friction hinge. Okay, I will tell you in this photograph. So now here are two friction hinges, right? As you can see, one is on left, one is on right. And there is a minor difference between both of them. As you can see, here there are two leaves are coming here, okay? Whereas here both the two leaves are merging at one point. And here one leaf is coming at this point and another leaf is coming at this point. So what do you think? Type in the chat box if current at 32.10. I think it's for 33.1. Somehow you missed 1 kg. Yep, 33 would be right answer. Okay, so now let's come on this one. If this is A and this is B, type in the chat box, what do you think? Which friction hinge has better load distribution? Okay, Ayush Khosla is saying B, Ankit Khanna is saying A, Mr. Ankit Malhotra is saying A. More answers. Mohammed Sultan is saying A. So as you can see here in this one, okay, in case of friction hinge number A, the load is going here, then the load which is coming here, because where is the main load? Okay, here it will be your sash. So entire load is going to come on this leaf, okay, this leaf. So from this leaf, it is going to distribute the load to this main leaf, okay. This part is fixed in frame, okay. This part is fixed in frame and this part is fixed in sash. So entire weight of sash is going to transfer here in the base leaf in the frame through these leaves. So here one point the weight is coming here and then it is going there and it is going there. So through 3 points it is distributing its and transferring its weight over the main base leaf on the frame. But what's happening in case of B, this entire weight, firstly, at one point, it is going here, and then this weight also and this weight also is coming on a single point. So if we want to go for a heavy sash, we will of course would be liking to go for A type, not B type, because better load distribution is on a type of friction hinge. For a lighter and smaller windows, you can go with B type. And now let's see more type. Okay. So here you can see there are two more types of friction hinges. Here This one is called egress. Okay. Type A is called egress and type B is called an easy clean. Normally, we have type B. Okay. So normally, we what we see in normal windows is this type of friction edge where, as you can see here, the friction edge is open. Okay, and when the friction edge is open, we get a space in the side of the sash. So from where we can clean it. Okay, clean the sash as I told you in the earlier slides also. So that's why it is called an easy clean friction edge. But what happens sometimes, especially in the cases where a building is fire prone or people are little afraid of that if in case of fire, how we will be able to go out. Because what happens in case of easy clean friction edge, when you will open the window, okay, then almost your sash comes at the center of the frame. So there is a huge space which is compromised. So it is very hard to get out of the window, especially if the width of the window is not enough. Okay, so it will be very difficult to get out of the window. So some clients would prefer that I need enough space. After opening the window, I need enough space so that anyone can get out of the window. So in that case, people could go for egress. So this one is called egress. As you can see, after opening, there is no space between your sash and the frame. But at the same time, if the client does want that, I also want to clean it, how I'm gonna clean it. So as you can see, here is a tool, right? So this tool, there are two hooks here. So you struck it here, then you drag it, pull it. Then the entire sash will be dragged here. And then you can clean the sash with the glass from the outside. And once you will close the window with the handle, it will automatically go in its original position. And next time you will open it, then it will open it in its original position. So while the client wants to clean it, it can use this tool to fix her, pull the entire sash here, then he can clean it. And then again, as soon as he closes the sash will go in its original position. But yeah, 99%, 90% of times we see easy clean options. Egress options are not so much seen. But yeah, if your client wants that, then you can suggest this option to your client that yes, we can have that option also. Then here, as you can see here, we are having two types of uh, more friction hinges. It is a self arrowhead and the self balancing one. As you can see, it is symmetrical. Okay, the head where which is go inside, it is symmetrical as well as it is asymmetrical. And this point here, it will go and it will lock here. So this type of friction hinges, they are mainly used for very heavy sashes where the weight of sashes is a lot, and as well as if it is heavy and also and top hung also. So for heavy and top hung windows, we go for this type of friction hinges. As you can see here, this leaf is coming here, and whereas here the leaf is coming here. So it is designed to take much more load, much more weight than normal friction hinges. And as you can see, it goes and locks here. So it gives a much more better locking when it is in the top hung position, because in top hung, the position of the sash changes as compared to a side hung window. In a top hung window, the entire weight of the sash will come on the one top point. So this is the top point where the entire weight of the sash will come. So that's why these types of friction hinges are much more preferred in case of heavy and top hung windows. For a lighter windows, you can of course go with this one. But if it is a heavier one, this is a better option to go for. So as you can see here, now we are talking about the butt hinges, these small hinges which are used in the casement windows. And as you were talking about the weight, so normally in case of friction hinges, what happens? Somebody was asking me this 30 kgs is for one hinge or two hinges. Okay. In case of friction hinges, it is always for a pair. Okay. If a company is claiming that X type of friction hinge can bear a weight of 30 kgs, then it guarantees that two hinges of that type will appear. The weight is always given for one pair of friction hinge, whereas in case of a butt hinge, the capacity is given per three hinges. Okay, that this type of three hinges can take a weight of XY जितना भी kgs है 30 kgs 40 kgs 50 kgs. So three types of that hinges can bear a weight of so much kgs. So, but in this case, for example, any company claims that X type of hinge, it can bear 60 kgs weight. So it is claiming that three types of such hinges can bear 60 kgs weight. So it doesn't, and if your sash weight is 70 kgs, okay, and then what you do, you add one more hinge. Then your calculation says that if three types of such hinges can take 60 kgs of weight, then if my sash is coming for 70 kgs, let me add one more hinge to bear the weight. But in that case, may or may not your system would work. But if your system fails, if those four hinges are not able to bear a weight of 60 kgs, then in that case, the hardware company won't be sticking on to their guarantees because they have guarantees for just three hinges. So if you're using four hinges for more weight, then it won't be feasible. So in case of butt hinge, what happens? As I've told you, when there would be wind or airflow, your sash will move freely, okay? And that is a big problem, especially in case of high-rise buildings. So for that purpose, so that uh, there is a restricted movement of the sash, with a butt hinge, we use this windbreak arm, or normally we call it friction stay. So friction stay is attached with in case we are giving butt hinge to our sash, so that our sash doesn't move freely. Okay, it has a restricted movement. Now we are coming to casement door hardware. Casement door hardware is very similar to casement window hardware. As I've told you in case of casement window hardware also, that we need to assure that the overlap is not compromised and we are at least maintaining an overlap of 8 mm between the sash and the frame. So this is the overlap. I think now all of us has understood that. So indoors, people do give a single point locking through some mortise locks, but we as UDMA, we never say that you should give single point locking in a door. Okay, must always give multi-point locking in a door. So as I've told you, multi-point locking constitutes of spag, our handle, and our strikers. Spag, recently we have studied it, so I'm just running quickly through it. Same, exactly same things. But yeah, here the length will vary from 1600 to 2400 mm. And the back set, of course, here the profile is bigger. So we will be needing a spag of bigger back set. So normally it ranges from 20 mm to 45 mm. And it will entirely depend on the profile which you are using. You have to select the back set of your spag based on your profile. So these are a few examples of a door spag. Okay, door spag is little different from window spag because in door spag we also need locking. So right now, as we can see here is a door spag in which here we can fix the handle and here we can fix the cylinder. Cylinder is for locking purpose. If we see closely, then what will happen here in these, this handle will be going in these three holes, and here there would be a cylinder, and on front and back this cover would be there, which will be covering the cylinder, and only this keyhole would be visible from this area. So there could be handles. As you can see here, what is happening? Here the handle is different and cylinder is different. But as you can see in this one, we have cylinder space and handle in single attachment. So in this, what's happening? In this case, the spindle hole and the cylinder hole is in the same area. Whereas in this one, we are using separate. Cylinder is separate and the keyhole and the handles are separate. So this entirely depends on your client, what he chooses, with which design he wants to go with. Here also we will go with the same formula, that we will take a maximum gap of 200 mm while selecting our spag. So we will calculate our inner sash heights, and the length of the spag should be 200 mm lesser and can be maximum 200 lesser than the inner sash height. So what is the difference between a window handle and a door handle? So window, we always operate just from one side, right? Inside. We never use a window from outside. So the window handle is from just one side, whereas a door we use from both sides, okay? From outside also and from inside also. So door handles are from both sides. Routing holes are same when we are using this type of handle. Otherwise, routing will be, of course, additional different when we are going for cylinders. For cylinders, different routing would take place. Base width, we all know base width. Then the spindle is same. It is also 7 by 7 mm, and this length would entirely depend on the profile you are using. Handle fixing, how it is done, as you can see, it is the frame, it is the sash, it is, okay, now tell me let's see who remembers things. Where's my pen? If this is side A, this is side B, okay? So which is outside? Outside kaun si hai? A or B? Just type in the chat box. Which is outside? Okay, everybody has typed B, 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 B. Yes, B is outside because as you can see, we always have to see where is the bead. Wherever the glazing bead would be there, it will be our inside. So how the handle would be fixed? The handle would be fixed like this. The spag is here, and then there is a handle, and there is a handle. One from inside and one from outside. This is the French door. I'll tell you a quick thing about this, okay? So as we have studied in our first session about the French window, I think somebody would have remembered that there are two sashes, and both sashes open, and there is no fixed mullion in the frame. There is a floating mullion in the slave sash, and there is a handle in the master sash. So this is our slave sash. This is our floating mullion. This is our master sash. So as you can see, this is the slave sash. So this floating mullion, it is fixed in the slave sash. This is a lap joint profile, which is fixed on the floating mullion. And then on this, there is a striker. Here is our spag. As I've told you, in the master sash, we have our spag, and our handles are in our master sash. So as you can see, here is the handle, Here is the spag, and there is our slave sash. And the sorting mulin is attached to the slave sash. There's a lap joint profile to cover this groove, and this on this lap joint profile we have fixed our striker. So this our spag is going to come and lock in this striker. So while selecting a striker, we need to see this gap. Okay, line halki सी टेढ़ी हो गई है. So basically, it is the gap between the center of the spag, wherever the center of the spag, to the side of the frame. So this gap between the center of the spag to the side of the frame is called the system axis. And depending on the system axis, we choose our striker. So we have to tell the hardware provider that my profile system axis is XYZ whatever, and then he will suggest you the striker depending on the system axis of your profile. In a door, normally we use 3D and 2D hinges only. So this section, it is fixed on the frame, this part, bottom part, and this is fixed on the sash. So both 3D and 2D hinges, their function is same, but the difference is, as you can see, 3D hinge looks better and it is much more expensive than the 2D hinge. And also its weight carrying capacity is much more than the 2D hinges. So we have recently learned how we can select our hinges based on the weight of the sash. So here we are mentioning that we are selecting the hinges based on the weight carrying capacity of the hinges, and the weight load capacity is considered per 3 hinges. As I have told you recently, it is considered per 3 hinges. For example, if weight load capacity of type A hinge is 150, then it means that 3 number of such hinges can hold a maximum weight of 150 kgs. So here just tell me, okay, so we are having a door sash of 100 kgs. Okay, so what do you think, which hinge we can use for this? Type A, B, C or D? Which hinge we should use for this door sash? I'm not getting many answers. Only Mr. Ankit Malhotra has answered. Please come on, guys. Which hinge? Okay, I've got 4 answers. Where Ankit Malhotra is telling CD, Mr. Brain, B, Karan Shah, CD. There are 19 people. Okay, so apart from me, there are 18 more people, and I'm not getting so many answers. So Shahzad is telling it C. Ayush is telling it C. Krishna Joshi is telling it C, D. Okay. So yes, 80 of course we can't use it. 100 hai. 90 we can't use it. 100 of course we can use 100. 110 of course we can always go for more. Okay, we won't go for less. So we can use type C also and type D also. So now let's see how the hinges are placed while fixing the hinges in a casement door. So for a sash weight up to 900, for a sash width up to 900 mm, normally what it's done, first hinge is it's placed from 250 to 270 mm from top. Okay, we fixed it. Then the second one we place similarly 250 to 270 from bottom, and the third one we do it at the midway of both the hinges. But I mean, it's not, I mean, written somewhere, you can always talk to your hardware provider that what they suggest. Okay, this is a suggestion through by one of our hardware company member. So you can always consider whatever your hardware provider is suggesting you. So when the sash width is larger than 900 mm, so just think, okay, so it is a big sash. So when the sash is width wise it's bigger, then at which point the maximum weight of the sash will come. Type in the chat box top, bottom, mid. Okay, which is the point where the maximum weight of the sash will come, top, mid or bottom. Hmm. Yeah, I've just got one answer from Mr. Karan Shah. Any more answers? If the width of the sash is more, what do you think? And in other case also, where which at which point the maximum weight of the sash will come? Here, in the mid or in the bottom? Okay, top, mid or bottom? Where? Okay, I've got two tops and two bottoms. Three bottoms actually. Okay, Karan Shah is selling top, Shazad Shah is selling bottom, Ayush is selling top, Pramila is selling bottom, Ankit Malhotra is selling bottom. Okay, now let me tell you. Let me start the pen. Okay, so this entire weight, okay, it will come on the top here. If you will give enough support here, then the weight of your sash would be taken on that point. So this is the reason when the width goes up, the normally and in normal case also the maximum weight will come on this side only. So that's why what we do, our first hinge comes at a distance of 250 to 270 mm from top side. Similarly, bottom wala bhi. And the third hinges come from 150 to 200 mm from the top hinge. So here what we're doing, we are giving maximum reinforcement, maximum strength bearing capacity at the top. So now your sash weight could be easily borne by these two hinges. In fact, I think you could, in other cases also, I have seen many companies, even for lesser width doors also, they take this approach, okay? They fix two hinges at the top and then one hinge at the bottom for the better load distribution of your sash weight. So it's always good to ask your hardware provider that what they recommend, okay? Now we shall come to our sliding hardware. I think today our class will go till 5:15. Sure. So we are going for now sliding window hardware. So the way we have ensured that in our casement window hardware, in our casement door hardware, that the overlap should be at least 8 mm to ensure that our gasket is properly covered, properly sealed, properly compressed. Similarly, in case of sliding also, we will ensure that our hardware overlap, sorry, that our sash frame overlap is at least 8 mm. Why? Because this time we need to ensure that our wool pile is properly covered between the sash and the frame. Because the role which was uh, played by the gasket in case of casement window and casement door, the same role is played by wool pile here. Because as you can see, there is a gap between this frame and the sash. If I won't be fixing wool pile in this gap, so what will happen? The sound will come inside, dust will come inside. So for filling this gap, we needed a material, but we could not use gasket because gasket what will happen if we will use gasket? Gasket will stick, okay? And if we will fix gasket between the gap, then our sash, this panel, sliding panel, won't be able to move, won't be able to slide on your track. That's why we needed a material which could block the sound and air and dust, and as well as which will reduce the friction between your sash and the frame. That's why we use wool pile between our sash and the frame. But of course, the type of sealing that is provided by a gasket, it cannot be provided by a wool pile. So from this gap, somehow dust will come, sound will come, air will come, but it reduces it to a certain extent. This is the reason I was telling you that whenever if your client emphasizing on giving you and asking you for a dust-free, a sound-free solution, then please never give them sliding window options, okay? Even if your competitor is telling them to go for a sliding option because it is economical as compared to casement windows. So there you can, it's your duty to make them aware that it is not a perfect solution for a soundproof or dustproof solution. What are the sliding window hardwares? Bump stopper. Bump stopper is used to stop the bumping of a sash into the frame. I told you yesterday also that when this sash will come, when you will be opening it, then it won't be going and bumping the frame because this bump stopper will stop it. At the same time, just imagine this one is closed, okay? And when you will be moving this one, then the same bump stopper will be stopping it to bump again. And then as you can see here is a small accessory. It is called anti-lift. As you can understand from the name, anti-lift. So it is fixed one at the top and one at the bottom in the center of every sash so that nobody can lift the sash, take it out and enter inside the home. So it is for the safety purpose. Then we have our single point lock handle here. Single point lock, if you remember, in casement window, the name of the single point lock was Cox per handle. And here, in case of sliding windows, the name of a single point lock handle is flush lock or touch lock. And here is a single striker to lock this handle. So that's why it is a single point locking handle. There is no spag, okay? Spag only comes when it is a multi-point locking system. So it is the single point lock, that is flush lock or touch lock, and here is the striker. So it will come and lock in the striker. Here is our spag for the multi-point locking. We have our handle and then our strikers. These are the strikers where the cams of our spag are going to lock. Rollers, of course, rollers are fixed at the bottom of the sash so that they run smoothly over the frame. Here also we have two type of system, single point and multi-point. Single point is called touch lock or flush lock, and then it is its striker where it goes and lock. One more locking handle for single point is there, which is called a crescent lock. Okay, so mostly it is used between the two sashes. It can be used on sides also, but normally it's used on in between the two sashes, basically to give an economical option. But nowadays crescent lock is hardly used. In earlier times when these windows were new na, crescent locks were very popular. But nowadays people normally go for touch locks. Crescent lock is not so popular nowadays. So now spag, it also has a base plate. It also has a mods portion and then a spindle hole where the handle spindle will come. Then we have the holes for fixing the screws. But as you, if you remember, in case of our casement window, we had roller cams. But in case of our sliding spag, we have our mushroom cams. Okay. So you can look at the cams and you can easily tell that it is a casement spag or it is a slider spag. So its length also mostly varies from 400 to 2000. in case of a window. And its backset, normally you will find just two types of backsets in a sliding window, 7.5 mm and 15 mm. If you remember, in case of casement windows, the backset were varying from 19, then 20, 21. But in case of sliders, we mostly have just two backsets, that is 7.5 mm and 15 mm. And you will choose it depending on the aesthetics of the profile. Mostly for a window, we go for 7.5, and for a door, we go for 15 mm. So here you can see the difference between casement window spag and a slider window spag. As you can see, cams are different, right? Roller cam, mushroom cams. Then the shape of the mortise portion is different, and the back set is different. Here we have just two back sets normally, and here the back set can vary. Handle, it is a D handle. As you can see, it is making the shape D, and we can operate it when you will be moving this knob. Then your spag will be operating. The cams would be moving up and down, and here the cylinder could come and you can lock it. And then here we have our L handle, and here your cylinder will come. So here also, while selecting an spag for a sliding window, we will go with the same formula, that for the inner sash height we'll calculate, and then we'll go for minimum, I mean maximum difference between the spag and the inner sash height will be 200 mm. It's a door, and the door spag mostly varies from 1600 to 2400 mm, and the selection formula would be same. We'll go for a maximum gap of 200 mm. Routing holes, these handles are same. In fact, we can use this broader width sliding window handles in the inside opening casement windows also, because this thing is same. The spindle and this difference between the holes is same in all the handles at universal. It's all the same, the base width, the spindle and everything. Yeah. Now let's come to selection of handles. As you can see, there is a huge space. Okay, there's a huge space available for fixing the handle. So we don't need to worry about the base width of the handle while selecting a handle for a slider window. We can go with the thinner ones also and thicker ones. But mainly normally we go for the broader base width handles because they looks nice. So how do we fix the handle and the span in a slider uh, uh, system? As you can see, this is our sliding window profile. So we make a routing hole here and a mouth routing hole here. So from here, the spag will be coming, and from the this side, the handle would be fixed. And again, all those things which we remembered while fixing our handles in the casement window, we'll remember the same things, that our spag should not touch the gearbox and the reinforcement. Our spindle should not touch the reinforcement. And then how we are fixing the strikers. Strikers are fixed on the leg of your frame. It is screwed here, and then there is a span. This is why, this is the reason why the cams of sliding window spag are of mushroom shape, because its striker is of this shape. Okay, so these cams go and lock in this space. This mushroom shape goes and locks in the space. That's why it has mushroom cams. And of course, while fixing your strikers, we need to ensure that the gap of 8 mm is maintained. Now let's see a new handle which is called a pop-up handle. Okay, as you can see, it is closed and it is open position, and in the side it looks like this. Its dimensions are also same as our earlier handles. If you will see, L handle will look like this when it's fixed. B handle will look like this. And as you can see, the pop-up handle goes inside your profile. Only this few mm, 1 or 2 or 3 mm is visible from the outside. Otherwise, it's almost inside your sash. Why? What is the reason why we need this pop-up handle? So let's see the example. So these are three tracks of your window. These are the two glass panels, and this is the inner track. In inner track, you have your mesh. So what will happen now when you will try to move your mesh? This handle will stop it. This handle will stop the movement of your mesh because it is coming out of your glass panel. So what we can do? So this is a wrong option, okay? Whenever you are giving a mesh inside, you can't give both L handles or both D handles. Any handle which is coming out of your sash, especially the one which is near to the mesh. So second option is in both the handles, in both the sashes, you are giving pop-up handle. So now easily your sash can move. It has a space to move. Nothing is going to stop it here. And the third option is because this pop-up handle is little bit critical. I mean, it's little difficult to operate, especially in case of huge sashes. It is little difficult to operate, and after certain number of operations, because there is a spring inside, so it doesn't functions well. So people actually doesn't like pop-up handle much, but in case of mesh, we need to give it. So what we can do in this case, we can use L handle in outer sash and pop-up handle in inner sash so that it is not stopping the movement. And here this sash we can easily operate with the L handle. So the sash which is away from the mesh, any handle we can give, but the sash which is uh, near the mesh, we have to give a pop-up handle there. Another option is which normally people don't prefer, but we can give it if at any case he doesn't want to go for a pop-up handle in both the sashes. What you can suggest if he's ready to take the sash in the outer track. If the sash in the sorry the mesh in the outer track. If mesh is in the outer track, then we can give any handle in the glass panels. There will be no problem. Now we shall come to our next topic, which is rollers. Rollers are the that hardware of the sliding window or door, which are helping your sash to move on the track. So how you're going to select the roller, it depends on many things. It could be a metal roller or a PVC roller. In metal, we are meaning the wheel. The wheel could be of metal or it could be of PVC. It depends on you which type of which you want to select. And it also depends on the type of rail, the rail you're using. You're using aluminum rail or you're using a PVC rail. Because if you're using an aluminum rail, then never you go for metal rollers because metal creates friction and then your metal rollers will get uh, distorted very quickly. So especially if you are going for an aluminum rail, so I would suggest you to go for a PVC roller. Then the roller could be single or double. It depends, mainly depends on the weight of your sash. If your sashes are heavy, then normally you're going for double rollers. If you're having smaller sashes, then you're going for single rollers. Yeah. So this is possible in PVC also, metal also. So the same single and double, you will be finding with PVC rollers also. Okay. Then wheel type, you can go with groove or without groove. As you can see, there is a groove inside. So with groove rollers, I mean nowadays mostly with groove rollers are only preferred because they have a grip over the rail because it is the groove easily fits in this on the rail. height adjustable, there are normal screws as well as height adjustable screws. Adjustable screws are a little expensive, but the main advantage of height adjustable screws are, firstly, they are having better load carrying capacity, and secondly, as you can see, there is a small screw here, right? So you can tighten or loosen it, and you can adjust the height of the screw up till 0.5 mm, 0.5 to 1 mm. So what happens there, if you're adjusting these screws, is there any alternate to pop-up handle? Okay, as far as I know, a few companies, they are telling that they have their own customized handles. They are giving a different type of touch lock, okay? And that touch lock is attached to a spag. I saw this recently. I visited Tor Fenster's showroom, okay? So they were telling that they developed this hardware, this handle by themselves, in which they were having touch lock plus spag. Okay, so their touch lock was actually multi-point locking handle. So they could easily operate it through just one push. Yes, yes, huh. Toss Fenster has is using it. Otherwise, I haven't seen it much. If any hardware providing provider is giving it, I have not so much idea. But actually, recently, I have seen in an apartment also, and I don't think that apartment, because I don't know who fixed the windows there. But there also, I saw this touch lock within a spag. But who was the hardware provider? I don't know, because that was an apartment. Actually, that's my brother's apartment. He's living on rent, so there I saw there was also this touch lock within a spag. But otherwise, I don't know if there is any other option for this pop-up handle replacement. So now we are coming to this roller thing. So height adjustable screws, they are especially, so as I've told you, they have better load carrying capacity, and their height could be adjusted, because what happens sometimes, the main critical part in a sliding window is its sash alignment. Sometimes it's perfectly fine in the factory, okay? It looks perfectly, the alignment and everything looks cool in the factory. But once we install the window on the side, little bit of misalignment results in misalignment in the sash. So what happens? The sash is little bit misaligned, so the cams of the spag doesn't lock in the striker, because that they are not falling into a straight line. So at that time, up till a little bit of a range, that could be fixed with the help of adjusting the height of this adjustable screw. But after that, though, if till that height the alignment is not proper, then you have to change entire glazing. You have to remove the glass, then you have to change the glass alignment and all. But till a certain height, 0.5 mm, I think so, not 0.5 mm, like 3 to 4 mm, you can go with height adjustable screws. Beyond that, then you have to change the entire alignment of the glass or your frame. So just like in case of casement sash, the entire sash weight was coming on the friction end. And for selecting a friction end, we were first checking the weight of the sash. Similarly, entire weight of the sliding sash is coming on rollers. So here also, while selecting our rollers, we will check the load carrying capacity of that roller. Now we all know how to calculate the weight of the sash. In case of sliding also, what we will do, the formula would be same, but instead of 2.4 kgs, you can keep whatever your sash plus reinforcement weight is. Okay, so you will replace that 2.4 kgs from your parameters or measurements, whatever you're getting from your profile and reinforcement manufacturer. So in case of rollers, when a certain company is telling that my roller are having a load carrying capacity of 30 kgs, that means a pair of such rollers. Okay, that weight is for two rollers, not for a single roller. So this I'm gonna skip because this we have already done. The formula is same. So how the rollers are fixed? So the positioning of roller is 80 to 90 mm from the both sides. Okay. So from the left side 80 to 90 mm, we'll fix one roller, and similarly second one from next side. So this thing also, I have also written follow system provider. If your system provider or your hardware provider is telling you something, then you can ask them first that what they are suggesting. Okay. If they're not suggesting anything, then you can of course go with these calculations. But if they are suggesting something else depending on their profile aesthetics and their hardware aesthetics, then you should go for that first. So this is how we are fixing the rollers with the help of screw. So how the rollers are fixed. So this is the track I was telling you about. This is the track which is fixed on the legs of your frame. So on this track, your roller will move. That's why I was telling you that the rollers will with groove are better because they very easily mouse themselves around this curve. These are the height adjustable screws. So with this plus, as you can see from this sign, you can easily increase or decrease height of your rollers. So this was our session on the